Okay, just really quickly, we are on 312. I'm going to do some more lecture today. We're going to do lab, okay? Depending on where you're at, how many have finished the one trial that they needed with the pH meter? Raise your hand high. Yes. Okay, so you are going on to, there's two that you need to do now. Shh, listen. There's two that you need to do with the pH meter. One is a juice, okay, and one is vinegar, okay? So you'll want to do a quick titration first with whatever one you're doing, either the vinegar or the juice first, it doesn't matter. Do a quick titration, find out about where you're going to stop. Start with 2 milliliters that you're putting in. Not 10, not 5, go 2. Okay? That's important. Okay? 2. If that in the 25 does not get your curve, go down to 1. Do it again.
So is it titration thing where it spins on the plate?
Yep. So you're going to be using the pH meters. Now, you can still do one of two things. You can take a picture of it, but on both the vinegar and your juice, please listen. On both the vinegar and the juice, you need to be able to determine where that point of inflection on your curve is and what your amount of NaOH that you've added at that point. So you might want to bring it in, use the cords and hook the calculator to the computer, and then use the Logger Pro, hit the little computer, find the USB, and bring down L1 and L2, and then you can see all your data. And it'll print your data with the graph. If you need help with that, I can help you. It's really fast and easy, and then you just print it off, and you've got everything on one thing. Okay? So let me know if you need help with that. All right, so having said that, we're going to do really quickly. We're going to go into a little bit of salts and buffers today. We'll get more in next time. We're going to do a lot of Ks today. Don't forget about Part A on your home lab part that you're doing with your pH paper. Okay, so don't forget about that. Some of you still have not finished Part B that's in the hood. Make sure you get that done sometime. Okay, so we're going to be in lab today. We'll be in lab next time. And then after that, it's the review. That day that I'm going to do review, I'll open the lab, but we'll be doing review. Okay? So might want to think about coming in and doing a tutorial to finish up if you don't. Okay, so when we talk about a hydrate. Okay, guys, I need your attention up here. We need to be quick. We need to be fast. I need you to have your notes out ready and writing. Okay? A hydrate is something that is a salt that hangs around with water. Now, if you leave NaOH pellets out, it will grab water from the air and actually turn into a puddle. A lot of times they have little desiccants that they put in your shoes or in your medicines. That's to keep the water out of them because it likes to pull water in. Okay? Water hydration is that water that is attached to the salt. So if we use magnesium sulfate, which is Epsom salt, it usually has 7 waters attached to it. And that is known as the water hydration. An equivalent of salt is the amount that will produce 1 mole of positive ions, just floating around in solution. Okay, so if I say it's 1 equivalent of salt, it's 1 positive mole of ions floating around in the salt. So these are just some things that we need to know about salts. Okay, some definitions that we need to be familiar with. Are we okay to go forward? Okay. All right, some reactions that yield salt. We have an acid and metal. When we have an acid and metal, we get salt and hydrogen gas. This would be like when we did that reaction, rate of reaction, when we had hydrochloric acid and we put the magnesium ribbon in a bubble. It gave off hydrogen gas. Okay? Acid and a metal oxide. A metal oxide would be something with over here on the left of the periodic table with oxygen. We would get a salt and water. When we have acid with a metal hydroxides are like our strong acid, our strong bases, lithium hydroxide, sodium hydroxide, anything that has hydroxide on it. When we get that, we get salt and water also. When we add acid acid to a metal carbonate, we end up with salt, water, and carbon dioxide. So we get bubbling carbon dioxide coming off. This is what we use a lot in baking. So when we make bread, when we make anything that needs to rise, this is what we're using. So when we use baking powder, baking soda, anything that has a leavening effect, that's what we're using. Also, bicarbonates can also be used because we get carbon dioxide also. So anything with carbonate or bicarbonate, we're going to get carbon dioxide. We're going to get that leavening effect where we get carbon dioxide coming off. Yeah. All right, we okay to go forward? Yes, ma'am.
What is that I stand for? Like H2O.
Liquid. It's an L. Yeah, that's the hard part if the fonts are sort of weird. Okay, going forward. Okay, acidity and basicity. Salts can have a little bit of acid or base to them. So if I dissolve the salt in water, sometimes I get a little bit acid or base solution. If the cation comes from a base, the anion comes from an acid and a salt. So I have to go back and I have to look at if this salt separates, did it come from a strong acid or a strong base? Okay, what happens because of that? Okay, we could have a weak acid or a weak base. And if it's a weak acid or weak base, we'll talk about here in just a minute. So coming forward, so sodium chloride, it comes from a strong base like sodium hydroxide and a strong acid like hydrochloric acid. Because of that, I've got a strong acid, strong base, NaCl is perfectly neutral. It's a 7. Okay, that's because it came from a strong acid, strong base. Yes?
So is anything that comes from a strong base and strong acid neutral?
Right.
It doesn't have to use
Right.
NaCl.
Right. But I'm looking at going backwards. So I say, okay, this could, when I'm looking at water, I'm going to add OH to the cation, the Na plus, whatever the plus is. I'm going to add OH to see if it is one of my strong bases. Anything that has a minus on it, I'm going to add to hydrogen and look and see, is it one of my strong acids? Okay? All right, when we look at this one, NaOH comes, the Na would pair with OH and become from a strong base. But the HCO3 would be H2CO3, which is a weak acid because it's not one of my 6 strong bases, or 6 strong acids. Because it came from a weak acid, when I dissolve this in water, it's going to be a little bit basic. Because the strong base is going to overwhelm the weak acid. Okay, does that make sense? So you have to sort of work backwards. Now if we look at this one right here, NH4, if I add that to, because it's a positive, to OH, it would be NH4OH. I've written it right here, NH4OH, which is a weak base. That's not one of my strong bases. It's not part of the Tetris pattern. But Cl comes from HCl, which is one of my strong acids. So here, my weak base is not strong enough to overwhelm the acid. The acid is much stronger than the base, so I'm going to have an acidic salt. When I dissolve it in water, it's going to become acidic. Yes?
Very good. Is that a typo? Should that be acidic? It's basic.
Yes. So there's one place on your notes about midway down it repeats basic twice. It should be acidic. Okay? All right, so let's look at these real quickly. This came from what? Or this come from what? LiCl came from what? So Li is going to go with OH, right? And Cl is going to be HCl. Are these strong acids? Is this a strong base? Yes, so it's a strong base. Is this a strong acid? Strong acid. So what's my pH going to be? Okay, looking at this
Where
one.
did the OH and the H?
So when I split my salts, I'm going to put the first part with OH, the last part put an H in front of it. Okay? Yep. Okay, so this next part here, this is going to become CuOH2 because it took 2 of those to go with it. And this is going to become HNO3. Is this a strong base? Is that one of our strong bases? Our Tetris pattern? No. This is a weak base. That's a B, by the way. What about this one? Is this one of our 6 strong acids? Yes. So what is the pH going to be here? Good, less than 7. Okay, what about this? This is going to become what? KOH, good. And this is going to become? It'll be H2PO4 minus. Okay? What is KOH?
Wait, why isn't it 2?
Ah, we're only taking 1. So we're only going to take 1. Okay, this one right here is a what? Strong acid, strong base, or weak acid,
I'm
weak base.
confused about how you know if they're strong or weak.
Okay, so if you remember, I'm going to go over here to the periodic table real quickly. If I go right here, starting at lithium, lithium, sodium, potassium with a hydroxide strong. Slide over, calcium, strontium, barium with 2 hydroxides are strong. So this tetras pattern right here are my strong bases. If I go to the other side of the chart and I start with nitrogen, my oxyacids are HNO3, H2SO4, HClO4. So the oxygens go 3, 4, 4. Okay? HNO3, H2SO4, HClO4. Those are my 3 oxyacids. Then it goes HCl, HBr, HR, HI. Those are my binary acids. Those are my 6 strong acids. Yes.
So it goes lithium, sodium, potassium, and then it goes, does it go calcium or strontium?
Calcium. So
Like
slide
calcium,
over.
strontium, and barium.
Yep. Okay. So if we remember our 6 strong acids and our 6 strong bases, then we can really remember what is working here. Okay. Now, guys, you got to stay with me. I hope you're taking notes. I cannot help you pass this class unless you put in an effort. Yes.
Oh, okay, so you said calcium, strontium, and then barium?
Barium.
Okay, okay.
All right. So here, this is a strong base. This is a weak acid because it's not one of the 6 acids. So this one is going to be greater than 7. Okay. Yes.
Is carbon one of the strong?
No. No. Starts with nitrogen, slides down to sulfur, then over to chlorine. So HNO3, H2SO4, HClO4, then you start at chlorine again, and you binary, HCl, HBr, HI. So I call it swooping down. The swoop is oxyacids, they have oxygen in them. Straight down, it's just binary. Okay, so going this way again. Calcium is a +2, it's going to be with 2 hydroxides. CO3 is going to be HCO3 minus.
Wait, why is there 2 on the OH now?
OH always gets its way. It always balances out the positive charge. Okay, so you need to know the charge.
So like on like for part C, like we didn't balance out that place.
Part C, we did. K is +1, OH is -1.
Okay, and then calcium's minus.
Right, but I didn't worry about how many K's I had. I just wanted to know what it made backwards. Okay? So, but with the hydrogens, I can only add 1 hydrogen at a time.
Okay, then why do we? Okay. I'm
Okay.
really confused. Like,
So hydroxide always has to balance to 0.
yes, okay,
But-
but then you
But
said
hydrogens don't.
you said for this one, like, we just like pull it out just to see if it was gonna be a strong or weak acid.
Right.
It would be a mix.
But I still balance the charge. Potassium's a +1, hydroxide's a -1.
Okay, so then up here, calcium's a +2.
So I needed 2 hydroxides.
Oh, okay.
Okay? So I'm looking here. Is calcium hydroxide one of my strong bases? Yeah, it's part of that tetras pattern. So it's a strong base. What about HCl3? Is it part of my strong acids? No, so it's a weak acid. That means what's pH going to be? Greater than 7. Okay, here really quickly. Magnesium is in the second column. It's going to need 2 hydroxides. And this is acetate, so it's going to be acetic acid. Okay, strong acid, strong base, weak acid, weak base, what?
Strong base.
Strong base. What's this one?
Weak acids.
Weak acid. So the pH is going to be
Greater than 7.
greater than 7. Here we go again. KOH.
So,
Yes.
why is the MgOH2 strong?
It's part of the, oh no, sorry. You're right. This one is weak. Sorry. It's just above calcium. So it is not one of our strong ones. So it's weak base, weak acid, and that gives us a question mark because we don't know what's going to happen here.
Well, how do we figure that out then?
Okay, this is a buffer. So this is a buffer that will, as I put acids in or as I put bases in, it will stay at that pH. What pH, I don't know until I test it. So this one is a buffer,
I get this. If the test is this, I get it.
okay?
Like that would just be the answer on the
Yep,
test.
that'd just be a buffer. We wouldn't know what the pH of the buffer is until we tested it, but we know it is a buffer. Okay, what about this one?
So KOH is strong, right?
Strong base,
And then the NO3 is
That's
also
strong.
strong.
So it's 7.
yep. Okay, got it? Yes.
So is the base always first?
Yes, because you're gonna be adding the OH, which is negative, to the positive ion. Okay, so the positive ion is always written first. Negative ion is always written second, that's where you add the hydrogen.
How do you know how much OH or H to add to each side?
So H, you always only add one. OH, you balance the charge. Okay? All right, going forward, write the formula for the acid and indicate the solid that can be used to prepare each salt. So, this is just what we've been doing, but they want a solid in an oxide form. Okay? So, if it's wanting it with an oxide, that means that first one has to go with an oxygen, not a hydroxide. Okay? Because remember the first one we had all those different types of equations? So this, instead of pulling it out now and putting it with hydroxide, I'm going to put it with oxygen. That's easy, right? So copper is +2 because I needed 2 chlorine, so it's going to go with an oxygen. That's my solid.
But is it?
That's going to need to be used to be prepared it. And it also asks me what acid. Well, I'm going to have to add it to hydrochloric acid. Good, I heard it. And that's going to give me copper chloride and water. And if I had to go back and balance it, I have to go back and balance. But they didn't say to balance it.
Where are you getting all of that?
Okay, because if we went back here, right here, I'm adding an acid to a metal oxide, I'm going to get salt and water.
Okay.
Okay, the salt happens to be copper chloride. Okay, going backwards. Okay, so going backwards here, it wants a solid in a carbonate. So I'm going to take magnesium, I'm going to put it with a carbonate. What's carbonate? CO3. Plus, what acid am I going to put it with? Look at that bad part now. SO4 minus, right? Okay, and then I will get, and if you put H2SO4 here, that's fine because you take one of the hydrogens off, but you would get a hydrogen sulfate instead of a sulfate. So this one, not really true. Okay, does that make sense? Yes.
So should we put all of our polyatomics on?
If you don't know them, I would put the basic ones like the carbonate, the acetate, the phosphate, the nitrate. Okay, yes.
Why don't you add this CO2 to the end of that?
So this one would make MgSO4 plus water plus CO2.
Okay.
Okay, but it didn't ask me to finish it. All it asked for was the acid and the solid that made it. Okay? All right, bottom one. Lithium bromide, I want a solid in a hydroxide form. What solid am I going to make?
Salt and water, right?
Lithium what? Lithium hydroxide, and that would be my solid. Good. Plus what acid?
HBr.
HBr, good. And on this one, I would still make lithium bromide and water if I wanted to write the other side of the equation. Okay, going forward. So, as you're doing what it's called when we put the salt with water, it's called salt hydrolysis. That makes sense. Hydrolysis means adding water. Okay? It's the reverse of the neutralization. So it's reverse of neutralization. So as I'm doing a titration and I'm putting the acid and the base together, I'm going to get salt and water. But sometimes that salt and water is going to end up acidic or basic. It's not going to stop at 7. Okay? So the reason why is this acid and this base go on to react with water and give me hydrogen or hydroxide. The K, if the K, the 4 forward reaction with the acid and the base. If that is neutral, then Ka and Kb are equal. If it's acidic, K of the acid is stronger. If it's basic, K of the base is stronger. So let's look at this. Have we written Ks before? I don't think so in here. Any Ks? All Ks are products over reactants. I do not write no liquids or solids. They drop out. Okay? The exponents the coefficients become the exponents. Okay? A weak acid has a Ka of less than 1, meaning it doesn't want to go forward. It's mostly reactant. And leads to a small pH. Base, same thing. I'm looking at how it reacts with water. I'm going to get an OH and something. The water cancels out, and I've got my base to start with.
Will you go back to the acid, please?
Just remember, when you're writing Ks, there's no liquids or solids. That's really important. Okay, and if they have any coefficients, they become the exponents. So if there was a 3 here, I would put a 3 here. Okay? Okay, we okay to go forward? See that. Okay. I was just looking at the clock. Okay, so we have charts that we can go to that tell us what the Ka and the Kb of the acids are. Okay? That helps us to know how strong an acid or base is. Okay? And we can determine which way they're going to go. So acids, as I'm getting Ka very large, I've got strong acids. As my Kb gets very large, it increases in strength also. So, if my acid strength increases, my pH decreases. If my base strength increases, my pH becomes closer to 14 because my H3O plus decreases. Okay, sort of give you an idea here of what's going on. Okay. Okay, guys, I need you to zip it. I'm tired of talking over you. Okay? All right. If we look at these Ka values, this would be like a problem on the test. You need to be able to arrange them according to which one's strongest to weakest or weakest to strongest. You're looking at this value and this value. Okay? So if it's a negative and it's a small number, that's a bigger number than a negative that's a big number. So here, these ones would be one of my smallest ones. Can you see that? Which one of those two is the smallest? A. It is A. So if you think of it this way, it has 0.4 zeros and then 2 9. This has 0.000065. Which one's smaller? Okay, yes.
So it's the biggest exponent, then the smallest, like smallest.
So
Right,
it would be smaller.
right. So they want us to do it strongest to weakest. So which one would be my strongest? C. It would be C. Because this number's the smallest negative. Yes.
Oh, so like the bigger number is stronger.
Smaller. Well, you got to think of it as smaller because I'm going to have more zeros after the decimal.
So if there was a number of, if an acid measured 1, it would be pretty strong.
Yes. Okay, so we got C. Then what number comes next?
B,
Then what?
D, A.
D and A. Good. Okay, now we're going to look at the conjugate bases of the acids up here. In order of their decreasing strength, strongest to weakest. Now, conjugate bases are opposite of the acids because if I have a strong acid, its conjugate base is weak. So what are we going to do?
It's just the opposite.
Flip
A,
it.
D,
Yeah.
and C.
I'll just be flipping it. Okay, so you just sort of got to think of it in your mind. Yes.
So could you just plug all of that into your calculator and see which one's smallest? And
Yeah,
arrange
you
it that
could.
way?
You could. The problem is a lot of the calculators are stuck in scientific notation when you get this little.
Yeah, mine's
So if you just remember that this tells me how many zeros till I get to the number, that helps. Okay? And then you want the smallest number here is going to be my smallest number if they've got the same zeros. So if you look at it like this. Okay? All right. All right, we're going to write the dissociation constant. So first of all, hydrofluoric acid. What is it? HF. Good. When it dissociates, okay, it can go back and forth. When it dissociates, it becomes H plus AQ plus F minus AQ. Everybody okay with that? Okay, to write the K for this is really simple. This had to be AQ to start with in order for it to dissociate. Okay? So, to write the Ka for this, it's always products on top, reactants on the bottom. So for this one, I'm going to go bracket, meaning the concentration of H plus, and the coefficient's 1, so I'm not going to write to the 1 power. Coefficient here is 1 also, divided by my reactant, which is HF. That's my Ka. Way simple, way easy, way straightforward. Okay, doing it for this one right here, we're going to have ions. So HSO3 minus can go both ways. H plus plus SO3 minus 2 minus, and these are both AQ. Yes.
How do you know if they're AQ?
If they're telling me it's going to dissociate, it's going to be AQ.
Always?
Always. Anytime it has a charge, it's going to be AQ. Can't be a charge and be a solid. Okay? Yes.
How do you know if which one is the plus or the minus?
Hydrogen's always going to be positive.
Okay.
Okay, so over here, to write the Ka, again, we don't have any numbers in front, which is nice. We can just go bracket, H plus, bracket, SO4, 2 minus, divided by, parentheses, HSO, I forgot that was a 3, sorry. So 3 minus, and we're done. Okay,
So what is Ka again?
Ka is just, I'm able to put in and see, is the reaction really going forward or is it stuck in my reactants? So how quickly does it go forward?
How do you get that from this?
So this tells me here's my reactant, here's my product, here's my product. So when I go back in lab, I can test the pH. And I know that if I know the pH, this split evenly, right? So I get one of these and one of these for every one of these.
So it's always for
So that I can find that number. So it's another way I can find concentration. Because if I'm looking for this and I want to know what I have, I can look the Ka from a chart. I've got these two, I can solve for this. So another way I can do for concentration.
So when you're solving Ka, it's always products over reactants, and then
Always products over reactants.
and then it goes for like that. It's reactants to products.
Right, so let's do hypochlorous acid. Okay, this is hypochlorous acid. What is it going to make? What are you going to get on the product side? H plus, good, and
ClO minus 2.
the ClO minus, right? There's only one hydrogen coming off. So what's the Ka going to be for this?
It's H plus
H plus in brackets, good, and,
ClO minus
okay,
over all of the rest.
HClO bracket.
So then,
That's
what we plug? Is there anything to plug in, or is that just?
So you sometimes in the test she'll have you write it or have you pick which one's right, and then sometimes she'll say the concentration of this is this, this, and this. What's the Ka? So once you just plug in.
Once we have the pH of everything we can solve it. But
Right.
This is just how you set it up.
She also might give you the Ka and the pH. From the pH you can find the H plus, and the H plus is the same amount as this because this was one thing and it split into two. So if I know how much of this I have, I know how much of this I have.
So what does Ka actually stand for?
Ka tells me how forward how well the reaction is going forward. Okay, so is it really splitting? Is it really going into what I need it to go into, or is it staying back as reactants? Yes,
Why did we make the SO3? Why did we put 2 minus?
because it was already a -1.
Oh,
Yes,
How did you know it was the HClIO?
HClO,
Oh yeah.
because hypo means it's got less than OUS, and OUS came from chlorite, which is 1 less than chlorate. Chlorate is ClO3, so chloride is ClO2. Hypo is 1 less than that, that's ClO. Or you can look on the back of your periodic table.
Oh, that makes more sense.
All right, so here's another question like she has on the test. 5 solutions are made up according to the table below. Arrange these from weakest to strongest. This should be easy.
acids, right?
From weakest to strongest acid, yes.
So
what's my weakest acid?
D.
E.
No, it's A.
E.
It's A.
Acids?
No, it's E. It's E. I didn't see A.
Oh, I didn't see that.
Weakest
I didn't see
acid.
C.
Weakest acid is the strongest base. Right now, which one? Now E,
A, B,
and then
C,
A,
I mean B, D, A.
D, and then D.
Is it possible for an acid to be
You just
lower?
have to.
It is actually possible for an acid to be lower than 0 and a base to be higher than 14. Those are really, really, really strong acids and
I
bases.
was like negative 12.
So then what would be
So pure hydrochloric acid will be that.
Can it go?
Lowest I've seen is -2. Highest I've seen is almost 16.
What was the -2?
That's just pure. Because it's really hard, it's a logarithmic scale. So to have one that is that strong, we don't use it very often.
But what does the super low and super high do?
Keep your body alive.
what would be like a very strong base?
So it would be like your potassium hydroxide can make a really strong base.
Well, that what would that do to you?
So it would eat you.
Even a strong base?
Yep. Okay, so let's do this really quickly. I'm not going to write it. I'm going to have you try and figure this out. So in your head now, because she's going to be giving you these, we want to know about the relative pH of this. So I'm just looking at it and thinking, okay, is this a strong acid or this a strong base? So sodium. Sodium would go with what?
The strong base.
Strong base. So we got a strong base here, right? So that's sodium hydroxide is what that would be. Nitrate would go with what?
Strong acid.
Because it's nitric acid. Good. So what's my pH here?
7.
7. Did I write any chemical down?
No.
No, but you need to know your strong acid, strong base. Okay, sodium again. We already know the strong base. Nitrite. Nitrite.
Okay. Low. It's base.
Weak acid. So this is going to be what? Greater than 7. Okay? Okay? This one right here. Strong base. Borate.
It's a weak. It's a weak.
Yeah, it's weak. If it's not one of the 6 strong ones I know, it's weak. Okay, so what's this going to be? Greater than 7. Okay, potassium sulfide.
Strong base.
Strong base. Whoa, hello. Sulfite.
Strong acid.
Sulfite.
Strong acid.
Weak.
Weak base.
Weak. Sulfate would be a strong one, but sulfite will be. So this would be greater than 7. Lithium.
So does it mean strong?
Strong base. Remember the first one's base. Yes, Kyle.
I is weak because.
I are all weak.
It's weak.
Okay,
That
weak
is useful.
acid. So this is going to be greater than 7. Sodium carbonate. Strong base.
And
Weak acid. Greater than 7.
So since I is weak acids, does that mean that 8s are always strong acids?
Not always. Not
Has
always.
to go.
So you have to go nitrate, sulfate,
Oh, so then that's
chlorate. Those are the 3. Those are it. Okay? All right. We're gonna go back into lab one more time. If you have finished the first pH one, you're gonna go and either grab some vinegar or come to me and I'll give you some juice. You can choose some juice. You're gonna titrate one of them. You gotta get both a vinegar and a juice titrated. We fast and slow with pH meters, okay? Yep, and the buffer part is set up too, so if you want to do that, you can do that. Let's go. Hi ho, let's go, let's go.